Imagine, for a moment, standing at the very edge of existence. Not the edge of our galaxy, or even the observable universe, but the conceptual precipice of time itself. What would you see? What light, what energy would be flickering into being as the cosmos drew its first breath? For a long time, such a vision was confined to the realm of theory, a profound mystery buried deep in the cosmic past. But then, something shifted, not out in the deepest, most distant void, where the earliest light from the Big Bang still echoes, but remarkably, right here, close enough to touch in astronomical terms. Astronomers have recently peered into the heart of our own Milky Way and found a star that might just be the closest thing we have to a living, burning witness to the universe's dawn. Its name, in true astronomical fashion, is a bit of a mouthful: 2-mass J188200-5104378b. For simplicity, let's call it Star B. And what a star it is! This unassuming celestial body has been quietly burning for an unbelievable 13.5 billion years. To put that into perspective, the universe itself is estimated to be around 13.8 billion years old. Star B is, quite literally, nearly as old as existence itself. Think about that. This star ignited its nuclear fires just 300 million years after the Big Bang, a mere blink in cosmic time. It formed when the universe was in its infancy, a swirling, expanding soup of fundamental particles just beginning to coalesce into the first structures. And while it has already lived for an incomprehensible span of time, its journey is far from over. This red dwarf star is expected to continue burning for trillions of years more, a ridiculous span that dwarfs the current age of the universe many times over. Our own sun, in contrast, has only been around for about 4.6 billion years and has a lifespan of roughly 10 billion years in total. When our sun fades and countless galaxies have drifted away or merged, Star B will likely still be shining, a steady beacon in a vastly different cosmos. Now here's one of the truly astonishing surprises about Star B. It wasn't found at the far reaches of space, in some ancient, sparsely populated halo far from galactic civilization. Instead, it was discovered incredibly close to home, right here in the familiar embrace of our own Milky Way galaxy. For years, the oldest, most primordial stars were thought to reside only in the distant, diffuse halo surrounding the galactic disk, far from the bustling, younger populations of stars like our Sun. It was a logical assumption. The halo is the oldest part of the galaxy, the first structure to form, so it made sense that the oldest stars would still be there, untouched. But Star B shattered that assumption. In another surprise, it's located not in the halo, but in the thin disk of our galaxy, the very same neighborhood that houses our Sun. This is revolutionary. It means that truly ancient first-generation-like stars aren't just relics of the distant past in faraway corners, but can be found right alongside the younger, more evolved stars of our galactic suburbs. It's like finding a living dinosaur walking down your street. What makes Star B so uniquely ancient? Its composition. Unlike good old Sol, which is rich in a variety of heavier elements, what astronomers call metals, Star B is incredibly metal-poor. When the universe was born, it was almost entirely hydrogen and helium, with a trace of lithium. These were the only ingredients available for the very first stars to form. Metals, everything from carbon and oxygen to iron and gold, were created later on, forged in the furious hearts of these first massive stars, smashed together through nuclear fusion, and then scattered across the cosmos in the spectacular explosions of supernovae when those stars died. So, the stars that formed after these cataclysmic events incorporated these newly synthesized metals into their composition. Our Sun, a relatively young third-generation star, is rich in metals because it formed from gas and dust that had already been enriched by previous stellar life cycles. But Star B, with its stark lack of metals, could be just a single generation removed from the very first ever stars, the so-called population 3 stars, which graced the void with light and began the cosmic process of forging the elements essential for planets and eventually for life itself. Imagine, just for a moment, what this star has witnessed. It saw the cosmic dark ages end as the first stars ignited. It watched as the first galaxies slowly coalesced from primordial gas clouds. It observed the birth of countless star systems, the formation of our own Milky Way, and the long, slow dance of spiral arms. While our sun formed, lived its life, and will eventually fade, Star B will continue its journey, a silent, enduring testament to time. This discovery is more than just an astronomical curiosity. It's a profound reminder of the universe's incredible vastness and its deep, intricate history. Finding Star B so close to us, in our own galactic backyard, tells us that the universe holds surprises even in the most familiar places. It challenges our assumptions about where the oldest relics of creation should reside. And it offers a deeply humbling perspective. We, made of carbon, oxygen, iron, the very metals that Star B lacks, are a direct consequence of the universe's long evolution. Star B represents the beginning of that story, the almost pure primordial light that lit up the darkness. It is, truly, a star that watched creation, and it's still here, burning brightly, quietly telling us its incredible story. What are your thoughts on this ancient cosmic neighbor? Does it change your perception of our place in the galaxy or the vastness of time? Share your reflections in the comments below. And if you found this story as captivating as we did, please consider liking this video and subscribing for more journeys into the wonders of our universe. Until next time, keep looking up.